Layout tools have been used by builders since ancient man first began constructing sophisticated structures. Today, basic site layout instruments have evolved, but they are used for the same purposes: for establishing and working off of baselines and reference points, for controlling grade elevations, and for establishing line and turning angles. Basic site layout instruments are divided into two major categories: the transit and the optical level. Transits come in two basic types: surveyor's transits and builder's transits. Surveyor's transits, as the name implies, are used by surveyors to lay out property lines and for the initial survey of highway and pipeline projects. Surveyor's transits typically have a large compass built into the instrument that the surveyor uses to find bearing lines. The measurement is expressed in degrees from true north. Builder's transits are used to turn angles and set points on a construction project. Some builder's transits have a compass, others do not. These transits range from the fairly inexpensive home builder's transit to electronic digital instruments costing thousands of dollars. Basic transits have the same parts: a telescope or barrel with horizontal and vertical crosshairs, horizontal circles including a fixed circle scaled in 360 degrees, and a rotating circle. On the circle, you'll find a vernier scale used for measuring horizontal angles. A vernier is a short auxiliary scale inscribed on the rotating circle to measure fractions of degrees on the stationary circle. The rotating circle is equipped with upper and lower locking clamps and fine adjustment tangent screws to allow precise sighting of a point. In addition to horizontal circles, basic transits are equipped with vertical circles for measuring vertical angles. A basic transit has 2 or more leveling bubbles with 3 or 4 leveling screws, and a chain and hook suspended directly below the center axis. A plumb bob is hung here for centering the transit over a point. To set up a transit over an established reference point, first locate the point and then set the tripod over the point with the legs about 3 feet apart. Check to see that the top of the transit is placed directly over the point and secure the legs adjustment screws. Setting the tripod legs can be tricky, especially on uneven terrain. But this is a critical step. Take your time and set the tripod carefully. The distance for spreading the tripod legs will vary depending on the height of the person using the instrument. Before securing the tripod ferrules into the ground, level the top surface of the tripod head where the instrument will be placed. Use the eye-sight method. Look over the top from different angles and eyeball the tripod for level. Doing this will help save time when leveling the instrument. When you have the tripod as close to level as you can by eye, place the instrument on the top of the tripod. Insert the tripod mounting screw into the center hole of the instrument leveling plate and fasten it down. Tie the plumb bob onto the hook under the instrument with a slip knot. If the plumb bob is not correctly aligned, move the tripod until the plumb bob is close to the reference point, and then reset the ferrules firmly into the ground. Level the transit by turning the instrument's leveling screws while checking the leveling bubble. Remember the left thumb rule. Whichever way the left thumb goes is the way that the level bubble will move. Turn the leveling screws as needed and rotate the instrument by 90-degree increments, checking level until it is achieved in all directions. At this point, you should check the position of the plumb bob. If it is not exactly centered over the reference point, loosen the mounting screw. Move the transit on the leveling plate to perfectly center the plumb bob on the reference point, and then fasten the mounting screw. This movement is known as wiggling the instrument into position. When the plumb bob is correctly aligned, recheck level and center to ensure accuracy. You now have the transit set up and ready for use. The theodolite is a digital version of the basic transit, but instead of having horizontal and vertical circles and verniers, the angle being turned is shown in numerical degrees, minutes, and seconds on a small LCD screen. The theodolite's digital readings are more accurate than those of basic transits. In addition, many digital transits come equipped with an optical plumb instead of a manual plumb bob. The optical plumb allows the operator to sight through an eyepiece directly down from the axis of the transit to center the instrument over a reference point. To properly set up the theodolite over a reference point, first, locate the reference point. Now, open the tripod legs, adjusting the tripod head height about chest high over the reference point. Looking through the center hole in the tripod head, align the instrument so that the reference point is located directly beneath the tripod head. Level the top surface of the tripod head by the eyesight method. Eyeball it for level. Make sure that the tripod ferrules are pressed firmly into the ground. Ensure that the thumb screws or latches on the tripod legs are firmly fastened. Place the instrument on the tripod head. Insert the tripod mounting screw into the center hole of the instrument base plate and fasten it down. Look through the optical plummet. Now, align the reference point image with the center mark of the optical plummet target by turning the instrument's leveling screws. While supporting the tripod head and instrument with one hand, carefully loosen the tripod leg clamps and adjust the lengths of the legs to center the air bubble in the bullseye or level. To prevent the leg from moving while you are adjusting it, place your foot on the ferrule as you tighten the clamps. Check that the instrument is still properly aligned. Once you are satisfied that the instrument is aligned, it's time to level the plate. Turn the leveling screws as needed and rotate the instrument by 90-degree increments, checking the level until it is achieved in all directions. Looking through the optical plummet, confirm that the reference point image is still centered in the optical plummet target. If the alignment is way off target, you'll need to start over again. Transits are designed to be very versatile instruments for preparing site layouts. Whether you are establishing line points both vertically and horizontally, turning angles of degree, or establishing a consistent grade or elevation, transits are indispensable tools. Learning to use transits properly makes the layout job easier and more accurate. Unlike transits, levels are used specifically for establishing consistent grades and elevations. The level is not designed to take vertical line readings like a transit does. Instead, a level is used to determine an accurate 360-degree horizontal line. The level uses a grade rod to achieve proper elevation readings. Because the level's telescope or barrel cannot be moved up or down, in most cases the level is not set over an established reference point. The most common types of levels used in construction are the manual, the automatic, and the laser levels. The manual level and the automatic level consist of similar parts. On both levels you'll find a telescope or barrel with horizontal and vertical crosshairs, 2 or more leveling bubbles with 3 or 4 leveling screws, an eyepiece, focus adjust controls, rotation adjuster controls, and a base plate. Set the tripod legs about 3 feet apart and secure the legs adjustment screw. Level the top surface of the tripod head by the eyesight method. When you have the tripod as close to level as you can by eye, place the instrument on the top of the tripod. Insert the tripod mounting screw into the center hole of the instrument leveling plate and tighten it down. Level the instrument by turning the leveling screws while checking the level bubble. When you are using an auto level, most of them will have a built-in bullseye level bubble. Use the leveling adjustment screws to center the level bubble in the bullseye. The instrument will then automatically adjust itself on a level plane at 360 degrees. Turn the leveling screws as needed and rotate the instrument at 90-degree increments, checking the level until it is achieved in all directions. When the instrument is leveled at a 360-degree turn point, you are now ready to use the level. Using either the manual or automatic level for establishing grade and elevation will require 2 workers. One will look through the instrument and record the readings, and the other will hold the grade rod on an established point. Grade shots can be taken at any point on the job site provided the view between the instrument person and the grade rod person is not obstructed. To set up a laser level, you begin by setting up the tripod, following the same process you used for setting up the tripods for the automatic and manual levels. Level the top of the tripod by eyeballing it. Place and secure the unit on the tripod. Now, turn on the unit. The instrument will automatically start adjusting itself on a level plane at 360 degrees. A laser level is battery powered. Check that the battery being used for the power source is fully charged and the instrument is working before taking the unit out into the field. The unit emits a visible beam that spins 360 degrees once it has automatically leveled itself. The beam will not spin until the unit is completely level. The spinning beam indicates that the unit is leveled and ready for use. Unlike when using the manual and auto levels, this is a one-person job. One laborer can set up the unit, be the rod man, and record the readings. Once the instrument is leveled and ready to use, there is no need for a person to stay with it. All of the readings will be taken by the rod person using a laser sensor that attaches to the grade rod. The rod man attaches the laser sensor to the grade rod and slides the sensor up or down until the sensor locates the laser beam. Based upon these sensor positions, the rod person then records grade elevations for the job site. From these readings, the elevation checkpoint can be raised or lowered as needed to achieve a consistent elevation throughout the project. As is the case with manual and automatic levels, grade shots may be taken at any point on the job site, provided the view between the instrument and the grade rod sensor is not obstructed. When you have finished working with transits or with levels, keep them clean and store them properly. These are sensitive tools we rely upon to give us precise, accurate measurements and readings. Transits and optical levels have long been integral components of construction site layout and survey projects. If possible, work with an experienced laborer to learn to use these tools competently and accurately.